Okay, continuing in 5.4, the bottom part of page 2 of the notes. Let's do number 30 from page 327. If you printed out an earlier version of the notes, you'll notice that this is different. The picture I took of the problem didn't include the actual question. So let's read it here. When an airplane flies with the wind, it travels 800 miles in 4 hours. Against the wind, it takes 5 hours to cover the same distance. Let x equal the plane's rate in still air, and let y equal the rate of the wind. The following chart summarizes this information. And the question that they want you to find is find the plane's rate in still air. So we've read it. We're going to take a deep breath. We're going to read it again. The book provides a little table to use. You do not have to use this table to solve the problem. It's really up to you. I'll demonstrate as I do this a way that you can set this up without using the table. For some people, the table is really comfortable. For others, it's not as helpful. So you find what method works best for you and is consistent and makes sense. Okay, let's read it again. When an airplane flies with the wind, it travels 800 miles in 4 hours. So we've got a situation of with the wind, 800 miles, 4 hours. Against the wind, it takes 5 hours to cover the same distance. Let x equal the plane's rate in still air, and y equal the rate of the wind. The following chart summarizes this information. They use x and y for the with the wind, add the rates times the time equals distance. Against the wind, they subtract the rates times the time equals distance, and then find the plane's rate in still air. So we highlighted a few things here. You might want to maybe draw a little picture for yourself if you've got a little airplane. I don't claim to have any art skills, but if you draw a little airplane here and it's going with the wind, which means the wind is flying with it, okay, it's going to be going faster with the wind. On against the wind, so again, if you were going, if the wind was going this way, and here's your plane traveling against the wind, it's going to be going slower because the wind is working against it. Okay, so maybe a little picture to help you understand what's happening. And from there, do we have anything that we're going to bring to this situation? And we do. The fact that they're talking about distances and rates and times, we're going to bring the formula distance equals rate times time. And again, that's from Math 60. If you didn't memorize it during Math 60, you'll want to memorize it now. Same with the triangle equation from up above, because you will not be allowed to have note cards on your test. You will need to have this in your brain. So we're going to exercise our memorization skills this term. So let's look at what we know. Again, expecting, or our goal. What is the goal that we're trying to find here? And they ask us to find the plane's rate in still air. So we want to find plane's rate in still air. Now for me, the book uses x and y, but for me, I like to pick letters that make sense to me. So I'm going to let the plane's rate in still air be equal to p, and I'm going to let the wind's rate equal to w. Okay, so we want to find the plane's rate in still air, so that's going to be a certain miles per hour. Okay, so we're talking about hours in terms of time, miles in terms of distance, so your rate is going to be miles per hour here. So that's our goal, and I'm going to set it up so that p represents the plane, wind represents, or W represents the wind, and so we don't stop till we find out what P equals. Okay, so let's look at our setup here. If distance equals rate times time, then we've got two situations here. We have when you're going with the wind and against the wind. So these are our two situations. They're going to translate to our two equations. So we're going to set up distance equals rate times time, because that's the formula that we know to use here. So with the wind, which once we drew a picture we realized you're going to go faster with the wind, which means we're going to add the two rates together. they have a certain distance, and the distance that they're covering both times is 800 miles. So our distance of 800 is equal to our rates, and we set those up to be P for plane, W for wind, and if they're working together to go faster, then you're going to add those together. So we're adding P plus W, our rates, together. And then we're multiplying by the time, and the time they gave us with the wind is 4 hours. So we multiply that by 4. And then our second situation is against the wind. Which means that we're going to be slower, which means it has to be the difference between the two, and so we're going to subtract. And so you have the plane's rate, and then you'll subtract what the wind is taking away from that. So again, we have 800 miles as our distance, because they told us it was the same distance, and we have the plane minus the wind, because now it's going to be slower. And we look at our hours for that, and the hours for that one is going to be 5 hours. It takes 5 hours against the wind. And now we have our two equations. 800 is equal to P plus W times 4. 800 is equal to P minus W times 4. Let's get those into standard form here. We're going to multiply by the 4, multiply by the 5, and I'll go ahead and rewrite them so that the equals 800 is on the right. So what we'd have here is 4 times P plus 4 times W is equal to your 800. That's your first equation. And then our second equation, again, this was against the wind. Here's with the wind, and here's against the wind. When you distribute the 5, you've got 5P minus 5W equals 800 when you distribute that 5 across P minus W. I have my choice. I can solve this by graphing, I can solve this by substitution, I can solve this by addition. Let's see, just to be different, because I've done every problem so far with addition, let's do this one using substitution. You don't have to. You can use any of the three methods. You should get the same answer with any of them. In fact, if you're feeling comfortable with more than one method, you could actually use that to check yourself. So that'd be a great way if you're unsure on an exam with your first answer, try it a different way and see that you get the same answer using a different method. So I'm going to go ahead and use substitution. And again, this is just my choice here. And I'm just wanting to do something different for the sake of giving you guys different things to watch. So I'm going to solve this for, I think I'll just go ahead and solve it for P. So I'm going to solve for P here. So I'll do that by subtracting the 4W from both sides. So 4P equals 800 minus 4W. I'll divide both sides by 4, so I get P is equal to 200 minus W, and that's what I will substitute in then. Okay, so now I'll substitute in the second equation. So I have 5 times P minus 5W equals 800, and I will go ahead and substitute for P what I solved for in the first equation, 200 minus W. From there, distribute, I get 5 times 200 is 1,000 minus 5 times W minus the other 5 times W equals 800. That's 1,000 minus 10W equals 800. Subtract the 1,000 from both sides, you get negative 10W equals negative 200. Divide both sides by negative 10. I'm encroaching on the next problem, sorry. Divide by negative 10, you get W is 20. Positive 20, okay? And it'd be very tempting to, if you were on exam, to go over and look for 20 miles per hour and stop, because we've solved an equation. But this is where it's really helpful to have that goal sitting over here. All we've solved for is W, the plane's rate, and we got 20. But our goal here was to solve for P, the plane's rate in still air. Now, if I would have kept the goal in mind, I could have solved for a different variable. I could have solved for w here, and then once I substituted in, I would have been solving for p and I would have been done. But I didn't notice that the first time around, so now I just have a little bit left of work to do here. I'm going to go ahead and take that 20 and take one of my original equations here. I'll take the I'll take the 5p minus 5w equals 800, and instead of w, I'll substitute in the 20. So I took one of my equations from over here, I took my answer, plugged it in. So this is called back substitution, so that I can get my second variable. So you get 5p minus 100 equals 800. Multiply the 5 times 20 to get the 100. Add 100 to both sides, I get 5p is equal to 900. Divide both sides by, what did I get here? 900, and p should equal to 180. Let's see, it feels like I did something wrong here. Okay, so I'm just going to check this real quick here. So if 180 times 180 plus that is 200 times 4, that gives me the 800. And then 180 minus the 20 is 160 times 5, that does give us 800. So it is 180, so that's good. So I did that right. So the plane's rate is 180. Just wanted to double check that. Okay, so when you check it back in the original situation, it works. Again, if you check them back in your equations, that's fine to check your algebra. But if you want to check your translation, you want to check it back in the original. So the working together, that's 200 miles per hour. It would only take 4 hours to cover the 800 miles. Working against each other, you get a net of 160 miles per hour. And 5 hours is what it would take to get the 800. So those do check. So the plane's rate in still air is 180 miles per hour. We're going to pause the video, or you can pause the video now, take some time to talk it through, both equations, both problems that you've seen on this page. If you have any questions that you want to take to your help resource, whoever or whatever that is, the online tutoring or the on-campus tutoring, or come to class or your study group or a neighbor, friend, roommate, family member, make sure you've copied what you need to copy from the notes here, and then try number 26 down at the bottom of the page. And pause the video because I'm about to reveal the answer, and you can come back and check it once you've tried it. And the answer for number 26 is you should end up with 2 avocados and 3 apples. And when you're looking at what you can ask questions in class, these try problems, I would love to do these in class with you. So if you don't get that answer and you haven't been able to find your mistake, love to go over those.